activity here. It's going to take a piece of paper, and if you don't have a piece of scrap paper, I'll get you one. We're going to follow these labels, follow these instructions, and then it'll take a few minutes, and then we'll go on. When you draw your triangle, you make whatever shape triangle you want. You make it however big you want. When you label your angles, write them off in the corners. Don't put them in the middle of the paper somewhere, okay? But put them inside the triangle and push them out best you can. You're going to cut these angles. Okay, so it says, use a triangle, use a ruler, draw a triangle, cut off the triangle, so you're going to use your scissors and cut along the edge of the triangle. Okay, cut it out as neatly as you can. It's important to use a ruler. Let's not use that paper. I'll give you your scrap paper in here. Okay. We're going to cut the triangle in 3 pieces, leaving each angle on its own piece. So, for example, you might cut it through here, you might cut it through there. Now, a lot of you have done this. You need to remember that angles A, B, and C make up a triangle, right? The 3 angles of a triangle always add up to what? 180. And so angles A, B, and C add up to 180. Look at this. If I take this angle and put it here, and I take this angle and put that vertex right in the same place, and take this angle and rotate it around so I can put that in the same place. Okay, I get this, don't I? This was angle B, this was C, and this was A. What do those 3 angles add up to?
180.
180. What we're proving by doing this is that the 3 angles of a triangle, no matter which triangle you made, the 3 angles of a triangle add up to this yellow line, which is 180 degrees. Okay? So we're proving the triangle angle sum theorem. It says the 3 angles of a triangle always add up to 180 degrees. Triangle angle sum theorem. Here we go. Let's write that down, please. Let's try to get through these notes. So what we've learned from this, quiet, please. No matter what the triangle shape, the 3 angles always add up to 180. Okay? Now, we need to classify triangles by looking at their angles. This is all hand drawn, so it's not real neat looking, but let's talk for a minute about what kind of triangles do we know about. What kind of triangles have you ever heard about? Okay, let's use some names. Acute, obtuse, a right, okay?
Left.
No left. Obtuse, right, acute, and equilateral, where all 3 angles are the same. Yep. So obtuse angles has 1 angle greater than 90. A right triangle has 1 angle equal to 90. An acute triangle has 1 angle less than 90. And equiangular triangle has all angles equal. So those are the 4 kinds of triangles we have when we talk about classifying them by their angles. On the test, they'll say, classify this triangle by its angles. You have to tell me one of these 4. Okay? I'll pause so you can finish. We're also going to be asked to identify triangles by their sides. So what kind of triangles, what other kind of triangles have we ever heard about? What's that? What other kind kinds of triangles have you heard about? You've heard all these names. This is not new to you. It's not. You've heard this before. Maybe not been expected to remember it all, but you've heard about it before. What if I had two sides the same? Remember what kind of triangle that is if two sides are the same? So you've heard of equilateral?
No.
What's equilateral mean?
They're all equal. They're equal.
All three sides are equal.
It's pretty self-explanatory.
If no sides are equal, they're called scalene. The one that trips people up is this one. Doesn't say two sides equal. It says at least two. So that means it could have two the same or it could have all three the same. Excuse me. Which means that equilateral triangles are also isosceles triangles. So we have scalene, isosceles, and equilateral. And this is really one of those. It's just a special situation for one of those, when all three sides are the same. Most of the time, if you see a triangle with only two sides equal, you say, well, that's isosceles. And if you see a triangle that has all three equal, you would say, well, that's equilateral. But the reality is, if you see all three the same, you could say, well, that's an isosceles triangle. And it is. At least two sides are equal. Okay? So we need to know what these three are. So on the test, when you're asked, hey, identify this triangle by its sides, and you look at it and say, well, none of the sides are equal, then your answer would be it's a scalene triangle. Or if you see two sides are equal, your answer would be it's an isosceles triangle. And if you see all three sides are equal, then really you have two answers. But the most accurate answer would be equilateral. Okay? We pause while you finish that. We have one more concept. And you need a little background information in order to get it. And it looks like we have just enough time to get our notes done, and tomorrow we'll work on the lesson. Okay, angle 1 is an exterior angle. If we look at this triangle, angles 2, 3, and 4 are all angles inside the triangle, right? Angle 1 is outside. Just because an angle is outside the triangle doesn't make it an exterior. And so there's some rules that go with what is an exterior angle. One of its sides is a side of the triangle, and the other side is an extension of, I'll move back up, a second side of the triangle. So I'll pause, let you copy the definition of an exterior angle down, then I'll move it back up and we'll talk about it. Okay, now let's go back to the picture. It says one side of the triangle is a side of this angle, and the other side of the triangle is an extension of another side of the triangle. And so I think I said that wrong, but what I meant to say, to get this angle, one of its sides is this side of the triangle, and the other side is the extension of a second side of the triangle. So just because it's outside the triangle doesn't make it exterior, Dalton. Its sides have to be made up from one side of the triangle and an extension of the second side of the triangle. All right? There's one more thing I want you to do before. Oh, tell me then what angles here are exterior angles. Angle 9?
1.
Angle 1?
3.
3?
4.
4? 7? 6? Someone said 8. Is 8 an exterior angle? To get 8, I use this, right? Which is an extension of that side. And I use this, which is an extension of this side. Remember the rule? One of the sides of the exterior angle has to be a side of the triangle. These are both extensions. So number 8 Number 2 and number 5 are not exterior angles. Okay? Alright. We'll talk about remote and the theorem that goes with it tomorrow, and then we'll give you your homework, and that'll be good.